Start recording, start camera. Let's be quick. Quick. Test audio checkmates. Okay. All right. Cool. Everything's working, I think. Hello. All right. So this kind of took a little bit of time, but now this is I got a bunch of these different motor setups. By the way, all these motor setups, you're gonna need cooling just because the design of the overall V1. So we got a bunch of different cooling setups that I've set up for these different Skywalkers. I have 3 in total. So there's the stock, then there's the wormless one, and then there's the brushless motor, not brushless motor. This is the brushless motor one. And the other one is a stepper driver drum belt modded one. That kind of took a weird amount of time getting set up, but it uses a complete different like apparatus setup to rotate the drum. So it uses a belted setup. So it's a EDPM GT2 belt. And it uses, for now, it's not using a 2209 stepper driver. It's using like it's basically using a, I forget what they're called. Closed loop. It's using a closed loop driver setup. So, it costs like $6.99 for the board. It was pretty cheap to set up, but there's like all these different options. I'm going to set this one up first because, I did the most modifications to it, and I'll kind of show you what it looks like on the inside. And then we'll go over this one first too. This is the one I have set up for a somebody that wanted customized V1. When I say customized, it's just I added all the safety, heat sink, and then I also added the cooling fan for the motor, which is the hugest thing that you really need when it comes to the V1, because that's the thing that usually overheats and breaks everything. So let's move over to this camera. Anyways, this is a delicate setup for day. We'll move this to the side. So right there. It's right there. It's literally just a hole that you drill, and you just use your filter fan because no one ever uses that. No one's ever going to use that filter fan again. I don't. If you're using it, then I'm pretty amazed because it always clogs up my system, so it's pretty annoying. But yeah, the filter fan that goes on top, I always tell people not to use it, but you can steal the fan from there, and then you could use that to cool off this drum motor. You just gotta either drill a circle. You gotta use a hole drill or a Dremel. I did it on both, so I did a Dremel on this one and then a hole saw on this one. What size was it? I think it was 1.5 inches, or maybe 1 3/4. I don't know what that's. I only know that in American. I don't know what that is in the metric system, the better system. But you just cut a hole and you really just put this fan and you hook it up to the USB port, and you have this literally go from 120 degrees Celsius to 60 degrees Celsius. So pretty easy mod to do. You can also just get a drill and just drill a bunch of holes, as long as you just get airflow to it. But it's better to make sure it's like a circle so that it actually blows onto it and cools it off, but it just needs air. That's all it needs. So we'll close this back up. And when the way it's set up with high beam, we just set up to where the filter fan just turns on 100%. Because when it's at 100%, it's literally just 24 volts the whole time. Because I think it just divides the volts into like 6, 12, and then 24 to control the speed of the fan. Nothing fancy. So if you want to go from like, if you want your drum motor not to like spill oil all over your electronics and then cause a short, or you just don't want it to fail prematurely, then I definitely recommend doing this. We'll take this off. All right. So we're gonna set up this one. This is my, I guess this is my little baby. This is a little bit more modified one. This has this drum motor setup. So we got a worm drive with a custom coupler. They're all like, this is about like, I think that's 25 couplers, like $3, and I got a heatsink. You don't need it, but I have it. And then on the inside, I also have, is this the one I have? Yeah, so on this setup, I don't want to pull it out, but I have a, put it out over there. So this is a custom box. You can download it online. We have it out there somewhere on the Discord. If I open it up, you would probably see two things. You would just see the regular standard controller board, but it's the power supply that's completely different. This uses the same power supply as a Kaleido. So it's like a 90 watt versus a 25 watt. And I'm using that because I'm running this cooling fan. This bean cooling fan, which 3D printed case, and it's like it's this huge monstrosity. And because right now with the heat in the summer and where I live, I can't cool the beans within 5 minutes. So I think last night, I think my garage was like 70 degrees inside, Fahrenheit, and it was not cooling the beans in like 5 minutes. Questions? How about the new models with the external extension for the motor? You mean the new ones with the drum motor, like the planetary? You can use any 24 volt PC fan. Just make sure it has to be 24 volts. So it says, you can use a PC fan, right? You can use any fan that's 24 volts. If you got an extra 24 volt laying around, you could use that. If you want to hook up to your system, if you want to do a separate fan connected to its own power supply, then you can use whatever you want. 12 volt, you could use a Noctua if you have it, or if you have a step down, whatever, those step down converters that goes from 24 to 12, then you could put probably like a pretty sweet looking Noctua in the back. I think I'm saying that right, Noctua. The OG silent fans, you could put one of those in the back as well. Pretty it up a little bit. Really quiet too. But how about the new motors with the external extension for the motor? Oh, you mean the ones that hang out? So I'll show you. So those motors are utilizing this planetary motor. It is a 26 millimeter 24 volt planetary. The reason it's 26 millimeters instead of like a 36 millimeters, like the one you would use, is literally because they did not think of the design of the drum. So it literally butts up to here. And if you had a 36, it would be like right up to there. So now they had to drop it down, and they had to, like, at the bottom of this, they have to bend it so they can fit this in there. So they kind of just, yeah. They still have the overheating problems. I don't think they're going to have the overheating problems now because it's not encapsulated in the back of this. This whole back portion is basically a big ass heat trap. Like, there's no insulation here to block the radiant heat or any of the heat from the panel to build up. It just goes all back there. So like all this stuff touching, basically, I probably eventually I've got to come up with a I forget what they're called. They're not Micra. They're like this gasket stuff that the Kaleidos use for the back, where it's like not like a heat shield, but it's like it prevents heat from transferring. but it's not the fluffy stuff in a furnace. It's like, I can't think of the name. Is it Micra? It could be Micra. It's this thing, it just deflects the heat and makes sure it doesn't pass through, but I don't want, because if I could just get less points of contact to hit this motor mount, then I think I could pass less heat to the motor. Because right now with the way it's set up, the motor and the shaft are like put together, and then that, I believe that a lot of the heat is transferred through that shaft. Or if it was like a legit coupler, I don't think there'd be as much heat transferred. I'm not sure. I'm not really into thermodynamics, but for sure the heat's transferring from these pegs from the drum motor back. And that's what overheats this. And with these brushless motors, they're very sensitive to heat in terms of like reaching a certain point. They have an auto shut off at 90 degrees Celsius. If you can make it cheap, there's this, I don't know I forget what it's called. You could find it on Amazon, but there's like this like heat blocking material, and I forget what it's called. I want to say it's not Micra. It's something else. If you look on Amazon, you just put like heat blocking. It's not, it's like a sheet of like, it kind of looks like board, like a cardboard, but you put it in they put it in the back right here, so it just stops transferring heat to the electronics in the back. And that, I'm talking about the Kaleido. But yeah, they're here. All the heat is just kind of willy-nilly out there. So you got to put a fan in there to cool this off, and you need that heat sink to really like cool this whole motor body down. I think the big thing is this one is always going to have a lot of heat, but it's just the body of the of this motor that needs to be cooled off in order to run. If you look at a V2, they have an internal fan setup that's kind of ghetto rigged inside of here. You can see pictures of it on the Discord, but it's in here, and the fan is angled and it points up, but it's also pointed to where it gets air out of this, like where these vents are at. So it angles it up so it gets kind of cool air to cool this off. The biggest thing is you have to have cool air cool down this whole system. That's the biggest thing. And I think that was one of the biggest issues I was having about overheating, was literally this. Because even this motor was dying when I was doing one roast, because it would reach like 90 degrees Celsius. Even the stock motor, it's reaching temperatures up to 127 degrees Celsius. But as soon as you put a fan on it, it drops like half. I think the highest I've got it to was 70 degrees Celsius after 2 back-to-back roasts. And then there was one day I left it on for a few hours on PID just to run it without any beans in it. And the hottest that motor, I came back checking on it, was 71 degrees Celsius. And that was about like a 45 minutes on 200 degrees Celsius PID, just kind of keeping it there and having it run over time. But anyways, I'm gonna put this back together. So we'll put this back. There's also, for this one, I actually drilled in a thermocouple. I'm using Bear's wireless thermocouple setup, to where we have it where it does like ESP now, where it sends over telemetry wirelessly to the ESP32. And now you're able to like use that to add an environmental temperature probe if you really wanted to. For me, I put it right on the exhaust. I don't know if you could see it, but let me see if I drop it in. You don't have to do this, but if you want to, you can. There's my exhaust probe right here. But if you're into telemetry and you want to get into that, you can. But right here is where I have it set up. It's a thermocouple, and I have a max amplifier, basically on the ESP32 that runs on a wireless battery. And a wireless battery. It runs on a lithium battery. Sorry, that's stupid. It runs on a lithium battery, and it basically, the whole purpose of it is just to power that up. I haven't found a 5 volt power source in here yet to chuck it on. But honestly, I just have like a I got it set up to where I was just using a regular backup battery that does 5 volts to hook up to that. I have a setup of that I did before, but I'll work on that later. Because I still got to do a lot of testing. But this is the rig I wanted to do a lot of exhaust temperature testing with. And this is also the rig I wanted to have a decent cooler on. Like a bean cooler. But anyways, I'm going to put this back together. Oh, sorry, and also for that brushless motor, there's this knob right here, and this is basically a little board, costs about $3, $4 maybe, and it's a PWM board that you literally just you turn it up, it goes up to 250 PPS or whatever it's called, and 0. So if it's like 0, it's full speed, 255 for to stop it. I think that's pulse per whatever, I forget what it is, but it's PWM. So pulse width modulation. So it sends like these signals to the motor to run, and you just decrease if you want to go faster, lower it down if you want to go slower. The reason I set it up with this is because I have control of it, and I can still use the stock controller. So so if I wanted to keep using the stupid controller, I can. But it's also just cheaper, instead of like buying these fancy LCD ones that you can control you have to like use buttons to put in the whatever measurement. Like I can't explain it. I forgot how to explain it, but basically there's a range of 0 to 255, and using that number, it controls the speed of the drum. I forgot the unit that was, but it was like 0 to 255. There's some reason that was a big reason, but that just basically covers that from 0 to 255, and you move it around. If you wanted to go faster, you want to go slower, you just use this. And that's inside this little custom case. But anyways, let's go put this together. $223. So I'm gonna try as fast as I can to put this in. I'm still trying to redo my whole thing after I had a little bit of a leak in my garage. So I had a leak, and it kind of fucked up a lot of things in the garage. So I got to fix that sometime soon. So I've been out of stream for a while. But so far with this, mods costs, even with the ESP32, you're spending about $100 maybe on mods, if you're including this silly little fan thing. Yeah, about $100. You get the ESP32 S3. If you get the brushless 24-volt motor for the drum. And I think it's rated for 90 RPM. The less RPM you can get, the more torque it has. There's a wire stuck there. Before I start breaking it. Sorry, and I have a 3D printer in the back going off, printing out some of the stuff for another build for a heatsink holder. Oh, let me unplug this before I kill myself. So yeah, so as you can tell, I'm doing mostly mods for the V1 because I think it's the better value versus the V2. If you were to get a V2, it's kind of sucks, in my opinion. It's just because you spend like $700, or you could spend like, if a V1 sells for $450, I think it's $500 now, and you spend another $100. No, I think it's still cheaper. I forget how much V1s cost now, but they're cheaper. Yeah, that works. So this goes here. Ugh. So I'm installing this bean cooling fan. I think this is on the Discord too. So if you wanted this file, if you really, really wanted this enormous fan to run, you'll see why it's ridiculous. It's actually fairly hilarious how loud this thing sounds when you get going. So I'm gonna plug this in here. Pretty loud. Oh. So now we're going to install this fan on. Use a, I don't know if you got a drill press, use it if you got one, but I'm just going to use my old little Milwaukee. Sticker side is the blowing side, so the air goes this way. And then I'm going to widen this out so I can make sure I could just force that M4 in there. Let's do that now. The good thing about sheet metal, you could really just don't even need a tap. Just manhandle it in there. Now it's tapped. And I'm just gonna make sure that's lined up. And if you want, I also have a little template you can use if you don't want to do it this way. There's a little template online you can use. Oh, sorry. Make sure to have your safety goggles and don't use safety squints. Notorious for using safety squints. Doesn't give it. Just give it a little more love. See? Threaded. Here. See if this works. I gotta get a better connection. Cool. All right, that's working. So let me get the ESP32 on here. Time 2:35. All right. Doing so good. So ESP32S30. We're going to flash this real quick. Also have this nice little case that I totally found on the internet. It should fit right in. Okay. Okay. That camera died? I guess it did. Let me see what happened to that camera. Oh. Let's go check the camera. Oh yeah. We back? There we go. All right, we're back. Oh, let me see if there's any messages. Nope. Okay, cool. All right, so we got that set up. That's good. That's good. Let's install iBeam onto here. There we go. Boot, reset. Oh, sorry. Let's go ahead and go back to here. So if you want to upload HighBeam, you want to use ESPHome, that's what we use, and you download the bin file. Usually it's under JTAG. Hit connect, install, choose file. For me, what was the last one I used? Not the bridge. And we'll use this one. ESP32S0 2.32 bin. I think that's the latest one from Bear. You can either use Bear or you can either use Magnums, don't really matter. They're all good. Even Crewless has one, so if you wanted to do it that way. Oh, I found it. So you install it that way. Like Martha Stewart cooking. Boom, right here. I found this other one, so let's plug this in. Plug this in the back. Good. I turn red. Means it's working. I'm gonna unplug this one. You turn air server on. And the biggest thing is for this whole thing, I just want to see if the if this will die in terms of connection. Well, not connection, jump motor. If the jump motor dies. Good, works. So let me connect my phone to cast. This app. We'll go here. Right, we got HighBeam up. Let's turn it over this way. Rotate. Don't want to rotate. No? I guess you don't want to rotate. Let's do controls, make sure everything turns on. Good. Heater flickers, so I'll turn it up and down, see if the heater flicks on and off. I'm gonna turn this around. Okay, here's the front of it. So let's see, let's turn the drum on. Good. It's going a little fast, so I'll turn down the speed. Or turn up the speed, turn it down. Good. Turn the fan on. All right, let's warm this up. It's warming up. See if anyone has any questions, concerns. Oh. There's here. Okay. See if high beam's running. Good. I'm gonna put it up to 100 so we could speed this up. Don't put it 100. Bad me. So usually, if I don't have a fan on this motor, what happens is basically the motor just turns off because it gets too hot, right? So, have to make sure it's being cooled, otherwise you just run the risk of destroying that motor. So here's the fan. This fan running here. I'm just clearing the path because this one sucks air and it blows the beans instead of sucking the air out. It blows air into it. So here's the back. So just a little more. looks good. All right, this looks all set up. I just got to set up the wireless thermocouple probe and it should be good to run. I should probably pick the bean I'm going to use. No, be right back. I always get the Sweet Maria sampler, so I'm hoping I get another Yerg, but we'll see. They gave a lot of light roast this time around. And a pea berry. That's interesting. I haven't had a pea berry in a while. Another light roast, have a bright tea-like quality of plum. I'm gonna do the Brazil Patrocino, Farzenda, Pariso, heavy body and mildly present acidity, rustic dark chocolate, dried cherry, marzipan, a creamy mouthfeel. Quite the words. With accents of tamarind and roasted peanut. That sounds awful. So that's what we have up next. Let's see, what temp are we at? 124. Okay. We'll let that heat up for a bit. Sorry, 8 should work. It should work. Okay. $250. Oh man, I'm running. We'll have to pick up my kids at 3:15, so I'm running behind. That took me an hour. I thought it was quick. Okay, but I'm gonna edit this anyways. I'm gonna edit my first video. We'll see. I'm recording this, so yeah, I'm just gonna edit this. I'm gonna add the roast in later with this. But anyways, next time I got to be on earlier. Anyways, that is pretty much the drum setup. Well, let's go. While this is going on, I'm just going to show you the stepper motor setup. I'm just going to grab the camera, go for a little walk. Sorry, my whole garage is a nightmare. So I'm gonna go ahead, take this part out. This drum setup, you can't use a stock motor. You have to use pretty much an ESP32S3. But that's basically the setup. You got a belt. It's EDPM, so it's up to 90 degrees Celsius. Or no, 120 degrees Celsius. Then you got, of course, the pulleys. Then you got the pulley on the stepper motor. Then you got this LDO motor that's set to sit inside, but since we got to cool it off, we have to open it up anyways. So I got that opened up right here. I got a fan on top of there, a lot wider. Then of course, I'm gonna mount this thing. Usually it's supposed to go like right here, right? And that's usually goes right in there. I'm just gonna stick it right here. This is a closed loop stepper option that you can put on the back. Makes it pretty much just a closed loop stepper. I use this because it was easier than the 2209. And it runs a lot quiet. It runs quiet. It runs the most quiet out of all the setups. It's still going pretty good. So let's go bring this back over here. So I'll have to come back and we'll roast with this. I don't want to leave it on, but I got to leave in like 5, so I don't know if anyone has any questions, concerns, they want to improve anything, let me know. I've been like streamed in a week and I'm doing a bunch of stuff. I guess I show you the 3D printers. I just finished a print on here. My other mess. Another roaster that I'm doing another project on, but yeah, this is what I've been printing these little things on. This is ABS, or I think, or ASA, I forget which one this was. Little heatsink mounts. Pretty solid. Really nice layer lines on this. It kind of fucked up at the end. I don't know what happened. Probably not enough air. And I have this one. This is my PLA printer. This is my speed ABS printer. Then I have a pure ABS printer, not pure ABS printer, ABS printer over there that it's basically this printer, but it's set up for ABS, where this is just PLA. Kind of curious about the temperature of this thing right now. Well, it's not slowing down. Usually it's slowed down by now. All right, so tonight I'll try to stream the roast with this. Oh, look. I didn't put the PID on. It's 259 degrees Celsius. Whoops. I don't know if you see that. Whoops, my bad. Let's just dump out some of the hair. Well, let's cool it off real quick. So I'll be back on later to do the stream with this. And then I still got to test this other guy's unit before I send it out. So more on that later. That was about an hour. All right. So let me know if you have any questions, concerns. I'm probably going to edit this video. So, yeah, sorry. I'll see y'all later. All right. Thanks. Bye.